All right, today we're unlocking the real engine behind modern AI, neural networks. They're the core of pretty much everything from your phone's Face ID to all that crazy generative art you see online. So let's really get into what they are. So what even is a neural network? Well, to put it simply, it's a computer model that's literally inspired by our own brains. It's built from a whole bunch of interconnected nodes, or neurons, that do two things. They process information and this is the really crucial part, they learn directly from data.
Okay, to really get why there's such a big deal, we kind of need to zoom out for a second and see where they fit in the whole AI landscape.
I want you to think of it like a set of nesting dolls. The biggest doll, the overall goal, is artificial intelligence. Inside that, you've got machine learning, which is the whole idea of systems learning from data. And a super powerful type of machine learning, that's deep learning, which uses these huge complex networks. And right at the very core, the smallest doll that makes it all work, that's the neural network. It's the engine driving everything.
So here's the bottom line. Anytime an AI does something that feels, almost like magic, recognizing a face, understanding what you're saying, or whipping up a piece of art, you can bet there's a neural network under the hood doing all the heavy lifting.
All right, let's pull back the curtain and actually look inside one of these things. When you get right down to it, the anatomy of a network really just breaks down into three core types of layers.
First up is the input layer, and you can think of this as the network's eyes and ears. It's the part that takes in all the raw, messy data from the real world. We're talking about stuff like the individual pixels from a photo or, a bunch of numbers that represent the words in a sentence. Next, you've got the hidden layers. And honestly, this is where all the real magic happens. So each layer is basically looking for patterns in the data it gets from the previous layer. The first few layers, they're looking for really simple stuff like basic edges or corners or patches of color. But then as the data goes deeper, the next layers take those simple patterns and start combining them into more complex ideas. Like, okay, that edge and that curve look like an eye, or those shapes together look like a nose. It's like building with Legos, from tiny bricks to a whole complex structure.
And finally, after all that hard work, we hit the output layer. This is the part that gives you the final, clean answer. It could be a simple label, like cat or not a cat. It could be a specific number, like a house price. Or it could even be a probability, like saying there's an 85% chance this email is spam. So the whole flow is pretty straightforward, right? Data goes in, it gets processed through all those hidden layers to find patterns, and a final answer comes out.
But wait a minute, how does a network get good at this in the first place? It's not like someone programmed it with a bunch of rules. The answer is, it learns. And it does this through a really powerful, continuous cycle. We call it the learning loop.
The process is actually kind of simple, but it's incredibly powerful. First, the network takes a guess. It makes a prediction. Then it compares its guess to the right answer and figures out how wrong it was. That's the error. Based on that error, it makes these tiny little adjustments to its internal wiring to do better next time. And then it just does it again and again, millions or even billions of times. With every single cycle, it gets just a tiny bit smarter.
Okay, I know that might still sound a little abstract, so let's make this super concrete. With a practical example pretty much everyone can get their head around: predicting house prices.
So, imagine we feed a network a ton of data about houses. The inputs, that's our input layer, would be stuff like the square footage, the neighborhood, maybe the number of bedrooms. The hidden layers would then start to chew on that data, figuring out all the complicated relationships, like how a certain location combined with a certain size affects the value. And then finally, the output layer would spit out its prediction, the final price.
And this right here, this is probably the most important thing to get. With old school programming, a human sits down and writes a bunch of if-then rules. But with neural networks, there are no handwritten rules. You just show the network thousands or millions of examples, and it discovers the rules and patterns all by itself, straight from the data. Now, this ability to learn from data that we've labeled for it, that's incredibly powerful. But think about this. What happens when you have a mountain of data with no labels at all? How on earth can a network learn anything useful then? Well, that's exactly what we're going to tackle next time when we dive into self-supervised learning. Until then, stay curious.